All right, this is fairly technical sort of talk as well, so I'll try and keep it to the point. The slides are point form, and I'll try not to get into too much of the hairy detail. If you would like to know, please ask. And I've also tried to keep it at a level that hopefully we can move through it pretty quickly. What we're discussing is an application that's currently under development here on site. It's a liquid storage facility for products that are manufactured here on site. It's developed sort of from nothing as a feasibility trial, and for that reason the way that it's evolved here on site hasn't led to very good specification. I'm not trying to point the finger there about these guys not writing good specs. Sometimes we do, but in this case we didn't. We've got a tank farm, 12 tanks. They're in fairly diverse locations, hooked up by whole lots of pipes, whole lots of valves. The brief outline is that the tanks have got different products in. Some might be the same, some might be different, but the operators in the facility would like to be able to move stuff from one tank to another, get stuff in and get stuff out of the tanks, hopefully not contaminate, cross-mix the products, but also be able to do more than one thing at a time within these 12 tanks. So if it's possible with the routing of the pipes and the valves available, we'd like to be able to move stuff from one tank to another at the same time as possibly recycling one of the other tanks or doing a second transfer if the valves will allow. As I said, we're developing it on the fly, and we were coming up against problem of living and breathing, ever-changing type of situation with the physical side of it, and we weren't really getting anywhere with developing the software until we came up with this, what we feel is a fairly novel approach to the automation side of things. There's a simplified layout of the plant. This is why I wanted to stick because it's kind of small. Maybe I'll see how I go from back here. The larger squares are equivalent to a tank. The lines show pipes, and the square blocks in there show valves. The valving, although they're all drawn as square blocks, the valving, some of those valves are just fully manual. The system, as far as the automation goes, the PLC is not aware of the valve being there or being not. Obviously it's important to know from the automation and routing perspective whether the valve's open or closed. Some of the valves do have feedback, and some of the valves are also fully automated with feedback. So we've got a variety of different bits of equipment as well as the pumps. So the bigger picture there is what you see. Don't have to worry too much about it. Obviously the system's complex. There's quite a lot of permutations and combinations of valve arrangements that makes for a difficult job software-wise. Fairly easy, probably MacroView-wise, to say, well, we've got all these valves and we can draw the states of them where we know. Where we can't, well, we just sort of have to guess. You could come up with something of a design, but we didn't feel that what we were presented with was going to meet the customer's needs in the traditional sense. So as I said before, we've got concurrent modes being possible, and we'd like to be able to do them if they're going to be permitted. If something, another task that you want to start in the system conflicts with something that's already running, we'd like to flag that and not let it proceed. And the last point there, as I said, the design is emerging and changing during the construction. So as the client realises another feature or situation that they want to try and cover, they've added or changed valves, added or changed bits of pipe, and as they do that on the fly while we've already started working, it was making our head hurt. So we come up with a short list of desired deliverables, things that we would like to give back to the client as part of the project, and also something that would allow us to continue with our work towards an end. So we need a flexible system, something that will cope with design changes quickly and simply at short notice, and a system where we can give responsibility for the process design rules back to the client. We don't like to be responsible for mixing the wrong stuff with the wrong stuff. So we'd like to, at the end of the day, be able to show a simple design document to the client and ask them to approve it for us to implement and give that responsibility back to them. We need to have a system that's able to give us good feedback about setup problems, given that there's so many bits of equipment in that layout. A problem obviously with one bit of equipment can upset many parts of the operation. So we need to be able to give good feedback of that to the operator. And a system that can allow us to manage the valves that we have that don't have any automation at all. So the valves that are fully manual, that are part of the system, we need to have a system within our automation that can try and cope with the status of those valves. The problems that you might have with a traditional approach would be standard ladder logic, lots of normally open, normally closed contacts, leading into result gates that say yes, a whole lot of selection criteria for selecting a tank in a different mode, would be very large, very cumbersome, and prone to a lot of error because it would all be typed in by hand and would be quite difficult to test, we felt, and also with the fact of bits of equipment being taken on and off at will by the client during the design, we would be going back to scratch quite often. Changes to any sort of aspect would hurt the traditional approach. Also, the traditional approach wouldn't allow us to easily work out the effect of a modification to one part of logic. So we wouldn't want to get to the situation where we alter one piece of logic slightly and have it affect another outcome without us knowing. So cross-testing. Also, the traditional latching type approach doesn't easily allow you to set the plant up to a known state. So if you say, well, we're starting from a completely clean and empty state, you have to be getting in there and manually releasing latches and setting things up to a known state. We'd like to be able to do that with a sort of a one-shot action. Okay, so what we did, we leveraged off features in MacroView. It's good sort of database back-end, database integration to come up with a system where we give some of the complexity and some of the routing information back to an outside storage place, i.e. not the PLC. We've still got a PLC in MacroView. There's obviously many ways you could do it, and this is what we've come up with, which we feel fits our needs. We've got standard DBF files with records. Obviously that's common in MacroView. We're extending that to create databases which are maps of the valves and equipment that are involved with any defined tank transfer, tank operation that you may wish to design. We're going to manage those DBF files using an Excel spreadsheet. That means we can give that Excel spreadsheet back to the process engineer responsible, and while they understand what's going on in that spreadsheet, they can approve the data inside that spreadsheet for being loaded into their plant as a way to operate it. We're using I suppose integration of MacroView and DBF, M-shell scripting and so on to automate the change of operation of the tank. So the tank changes from a transferring operation to a receiving, or from a transfer to a recycle type operation. We're actually loading that new personality of the system into the PLC program on the fly. So we're dispensing a lot of the knowledge that the PLC might usually hold back to a higher place. It also uses, as I said before, traditional approach would use latches, contacts. We're using a lot of numerical status rather than actually latch status information to give us this solution. Okay, things that we assume in the design, we've got 12 similar but not identical tank subsystems. So each tank has associated with it just a single pump out the bottom of the tank. The pump can either send material back to the same tank or off to some other place, or if the tank is receiving, then that pump's not used by that tank and can't be used by any other tank. So each one tank has got one pump associated with it, plus a valve layout according to what you're trying to do with it. A tank can't be emptied while it's being filled. That's an assumption that we're making, so that we don't allow concurrently receiving with transferring out. That's a design rule that the client asked for, and it helps to fit with our modes being mutually exclusive, so we can't have receiving and transferring at the same time. And all valves are two-way valves only, so there's no three-way valves. A valve, no matter what type of automation it has on it, is basically an on or off switch to the product flow. Okay, nitty-gritty of the design. Each item of equipment, each valve or pump that we need to use for the variable map has got a traditional type of entity configured for it in MacroView, and a special attribute of that is called the style. And the style attribute is used to describe what type of automation level, say, the valve may have. So if it's got no limit switches, one or two limit switches, fully automated with an actuator, or what type of actual type of valve is, we call that the style, and we allocate a number to that style, so that if a certain personality of the valve, so that decide to add an extra limit switch, well, you keep the name of the valve and you just change the style number, and all of a sudden it is handled differently by the system. Extending that, we've got a tank type, which is a way of defining once the map of operations that are used commonly across the 12 tanks. So we're using that standard power of MacroView that everyone's happy with, that when you've got more than one thing the same, you define it once and reuse that code. A couple of short examples here. This is just a brief view into the entities database. Those W's there are manual valves. They happen to be manual valves with feedback. We're using the multi-level address field there, looking at the element number 122, or record number 122 there, which is bold outlined. It's a valve 2 type, and then the number, the first number in level 0 address there happens to point to the style. So that register 1402 holds a number which is equal to the style of the valve. The other stuff behind that point to limit switches on the valves and other properties of the valve. So that's used as part of the standard mimic type animation that you'll see on the screen. Talked about the tank type. This is one of those very large types that you only have to do once. It's got attributes in there of more than 150. We've allowed a space of 150 elements to be mapped by this routing type database solution, and on top of those 150 equipment elements, we've got a few other items, like the top item there, mode, which says a numeric representation of the current job that the tank's been allocated with. Okay, so we've used numeric mode numbers as we discussed. They become pointers to the current task. So mode 1 is different to mode 2. Mode 1 is a transfer operation, mode 2 is a transfer operation to a different tank. So by setting a number into the mode, you've changed the personality or the task of the tank for what it's currently doing. Some modes require multiple things to be done. In other words, a transfer operation has a setup phase, transfer phase, and a completion phase. So within modes we've allocated sub-steps to handle that. The reason for that is that we only want to reload the map personalities once on a mode change. We don't want to be doing it during the sub-steps of an operation. There's the MacroView graphic that's been developed on the back of that first picture that I showed up. We've got pictures of the tanks, we've got product names allocated into the tanks, and we've got colour-based status indication of each of the valves that are in use. Just zooming in case one of those was not quite big enough to see, so we put a level bar inside the tank, and pretty much just a zoomed in view of what we saw before. Okay, talking again about code reuse, we like to keep our testing to a minimum. So we develop these little bits of metascript with inside the colour change objects, and then we pass in the only thing that changes from one valve to another is the entity name. So we develop a little piece of code there, copy it from one to another, and we just pass in at the top first line there the actual entity name which you use to drive that colour change.
So one of the things that we use to a large, it's quite CPU intensive, but the CPU can handle this. We're using you see the send valve outline to color updates. We're using a trigger program to do all of the work. So if anything changes, you have to go into one trigger program, change it once, and then every single valve on the entire graphic is then done. So we were actually able to do this not really knowing what we wanted and create the graphic, and then as more and more requirements came in, we could go in and change one trigger program in one place and all the valve outlines would change, and that made a massive difference. Because when we first started, and I was just like, this is going to take forever. Because just every time you did change it, you got every single valve, and you wouldn't know where you were. So that was really, really useful thing. Okay. Sorry.
No, please interrupt. And there is an example of a touch panel that lets us change the mode of the tank. So once again, we use a common piece of code to change the mode of the tank, and we just pass in variables, which tank number we're dealing with, and those variables passed in are triggers to this common pop-up. So I suppose the assumption behind that is you're only changing the mode of one tank at any one time. I suppose it probably handles it whether you are or you're not, if you're doing it from another location. So within this pop-up, it allows us to set the current purpose of operation for any one of the tanks, or otherwise to set it to an inactive mode where a tank is doing nothing. Okay, talking about the map files, as we said, we're going to use Excel for that purpose, or we have used Excel for that purpose. Primary reason for that is so it can be administered by a non-programmer type personnel. We can give it back to a process chemist or someone for them to check. We've got 150 elements available within the PLC structures, and we're probably running at about 110 out of 150 currently. So we've got some space to go bigger if they decide to add a few more valves into the system. We've got a manually run dbase routine that converts the master XL file into individual tank map files, one per tank. And as we said before, a map file change is loaded to the PLC when the tank mode gets changed. So, say for example, we're transferring from tank 10 to tank 6 and we're finished with that job now. We want to transfer from tank 10 to tank 5. On change of mode, we reload a new map from the MacroView DBF data storage into the PLC, and the operation within the PLC of that tank changes from that point onwards.
So were you able to drastically reduce the complexity of the PLC logic then?
Absolutely, yes. Yeah.
And the real beauty of it was also, Brad, is that once we tested one thing, we pretty much knew that everything would work. And if we'd done it the other way, every single one we would have done, we would have to test. So.
We use a few things for efficiency. So inside the assessment of the maps within the PLC, the map is obviously a certain size of that 150 elements, and we need to know what each position in the map is for. We use a 0 in the map to say that we don't care about the state of that device. So in other words, that device or element of plant equipment is available to another tank state if it wants to use it. If we require a certain valve to be closed, then we put a number into that map to describe what we want it to be. If we find a 0 in the map, when we align all the maps up together, it allows us to assess for conflicts between one map and another. On change of mode, when we're sending a new map, we use a single command write to clear the entire map before loading a new one in. That lets us cope with places where zeros and numbers don't necessarily overlap. Only the required elements of the map are loaded to the PLC, so where I've said I've got 150 elements, the routine that Doug has written to run the DBF files into the maps only sends the values where there's actually a non-zero map requirement by the PLC. So once again, just slightly more efficient than sending zeros where you don't need to.
And it takes what, about 2 seconds to
It's
load the
not
map?
that long, yeah.
Not even that long.
It's very quick. And within the map files, the order of the fields doesn't matter. So the structure of the map file matters, but the way you define it inside the DBF file, the way we've put it together, means you can put the fields in any order. The field names matter, but the order of the fields within the map file doesn't matter. So if you decide you want to insert new valves and you prefer to insert it halfway across the map for reasons of neatness, or that's the way you'd like to represent it, then we don't hold you to putting it in a certain place. There's a small section of the map file. Across the top we've got fields. The field names, as we said, do matter. The last 8 characters in the field name there, for example, looking at the first one there with numbers in it, about the 5th or 6th one across, it's a V_08W0114. Well, the 08W0114 is a name that matches a configured entity, being the piece of equipment that we're concerned with. Looking down the left-hand side, this Excel document has all the map information in for all the tanks, so it's effectively a master document. So one document only to be maintained. Part of the routine that Doug's written in the DBase program extracts by the file name column, which is the very leftmost column, which tank is actually involved with that map. So the first lines 2 to 18 there are for tank number 10. So on running of the routine, it will extract those rows out of the column and then generate the tank 10 DBF map file out of this master Excel document.
Spec right before you go, let's go. So you can see that, just to explain how like that on column 2 there, that's a transfer from tank 10 to tank 1. So the mode is 1, so you're transferring from tank 10 to
Sure,
tank
yeah,
1.
okay. The mode column there is also defines the actual mode steps. So that each tank can have several different modes. We've got transfer to any other tank, and that's why the line that's got 10 and 10 there, which is transferred to itself, we call that a special mode called recycle rather than transfer to itself, and that's why that one's empty, because it's not actually a valid mode. The 20 is receive or 20 is recycle? 20 is receive, isn't it? Recycle, can't remember.
Recycle.
Recycle.
Valves. And the 3s say the valve must be open, the 4 say it must be closed, and the 10 there means it's a manual valve.
We're
So
getting to that.
Sorry.
It's all right. What do all the numbers mean?
There you go.
Okay.
Thank you, Bob.
This is part of the functional spec document that we're developing as we go. Left-hand column there says the style. So we talked about each configured element of the plant's got a style number associated with it, and then according to that style, we have a status associated with that style. The status is the number that's written in the map that says how you want the equipment to be for a valid route to exist. So, for example, a style 2, valve of the style 2, is an automated valve with 2 limit switches. It's got status values possible of 1 or 2, which either means open or closed. Moving down, we've got other possibilities for valves and single limit switches that might want to be, say, not closed by or open by default as being checked against a closed limit switch only. All the different possibilities and combinations there dealt with style versus status. So just flicking back to the map, the values that appear in each cell for the intersect points there are required status numbers as to be checked in the PLC to make sure you've got a certain route. Where you've got a blank cell, that becomes a 0 in the map, so it's a don't care state. Okay, special case we talked about earlier, we've got valves with no feedback at all. So we've got a fully manual valve, still need to know what position it's in. What we decided to do to cope with that situation is we're asking the operator to tell us that he's comfortable that the valve is in the position it's supposed to be. So on change of mode, we actually cancel all status that we're assuming about the manual valves, and we turn them all on in a flashing colour, and we ask the operator to confirm to us that the valve's actually still in that position. If they want to, they can walk away and check it and come back, but each valve has to be manually reconfirmed to be in the correct position. this is an example of that. So for a no feedback valve, we've got this confirmation pop-up. When you change the mode, if you've got any manual valves that need a reconfirmation, they'll have an outline flashing around the valve. The operator will need to go and click on that valve. You'll have this confirmation pop-up. Confirmation pop-up will be greyed out in the sense that's not applicable and only able to be clicked in the sense that you're confirming the valve is in the correct required position. Obviously you can close that and not confirm it, but you won't be able to go any further. If you want to go any further with that sequence, then you need to reconfirm that manual valve. Okay, once again we're using reuse of code here, so animations within that pop-up we were looking at. We're looking at within this pop-up the actual graphical element of that valve there, the red bit of pipe with the handle on it and the red product flowing up to a certain point. That's actually flashing when the state hasn't been confirmed, and after you've confirmed it the one time, it'll go solid. So that's what the top bit of code does there. It says if you're in a status number 12 of that entity, you'll be flashing it in the closed colour. Once the status is 10, that's been reconfirmed to the correct position, so we'll just return it solid in the closed colour. And then the activate script behind the confirm button simply sets the status to a 10. So it reads the status as a 12, and when you press the button it resets the status to a 10.
Are these like fundamentally important valves, or are they like overflow valves? You know what I'm saying? I mean,
Brad, you don't want to go there.
Some of them are important. You'll have situation like if the operator just decides to confirm valves that are not really in the right position, you'll have no flow switches and overpressure type detection elsewhere within the system that will make sure that you're not doing anything too far wrong. At this stage it's usually a question of cost, that clients decided that there's a valve there. They need to know the situation of it, display it, but it's not automated as yet. Potential to be automated or have feedback in the future, and that's part of why we're taking this approach, because it's so easy to change the style of the valve down the track and not have to rework the system too much.
But Brad, also the only way we could think of doing we can log when they click on closed that they have clicked closed. So if they do something and they say, but the system's doing, we can say, well, actually, and if they know that it's being logged, hopefully the operators will take some ownership and responsibility of that and actually, I mean, how else do you do it? So if you don't have any...
Well, I have to say in the pop-up where
Operators take responsibility.
When the operator gets to click, you could put the name of the guy who told him. You've got to happy about that, wouldn't it?
Well, okay, just briefly about the PLC. We're here to talk about MacroView, so I won't dwell on the PLC too much. It's a Modicon Quantum. It's running fairly fast, roughly 30 milliseconds, doing all of this work. We've got a shell or a framework of tank logic only, so it doesn't know anything about really what it's trying to do. All it's doing is checking status against the map, updating status for the equipment, and determining if it should either continue or stop the process has been asked to run. So it doesn't actually have any knowledge as such of the route or the job it's trying to do. It's just saying, here's a bunch of data, check the data you're given against the data that's live. If they match, good to go. If they don't match, report where the mismatch is, and that's pretty much all it does. So you've got the facility to clear the map to all zeros and generate the mode steps, or the sub-steps within a mode. The checking of mismatch is done using a subroutine. So we have one subroutine that checks and updates the status for all of those 150 equipment items, and that's done every scan. When we come back from that subroutine, if there's any mismatch, we report the pointer that the mismatch existed on. That gives a feedback straight back to MacroView to say exactly which valve's in the wrong spot. We look at the level in the nominated destination tank if we're doing a transfer. So the transfer finishes either when the source tank's empty or the destination tank's full. So we need to map in destination tank back to the logic to say this is what we're using as a cut-off point. And as part of the setup for a transfer, we do a product matching check. Once the sequence has progressed to a transfer being executed, the products in those tanks are locked, so they can't be changed while the transfer is operating. And there's a continuous route check running for the whole time through the mismatch. PLC subroutines, we use the subroutines extensively to keep everything else small, so we've got the status update, runs every scan for 150 items. The subroutine is nested so it recalls itself. We've got analogue scaling, so it's scaling 1 card per scan, 11 cards, and we're updating the mismatch tables for all tanks, 150 items every scan. So we've got fast response to any actual problems that are detected. And the special case of the valves with no feedback, when a mode change is executed on any tank, the status of all those valves is automatically cancelled, so it has to be reconfirmed. Just wrapping up, summary, the power of the design, I'll call that. So we said we can easily add and remove a valve from the system. We can easily change a valve style, say adding limit switches, taking them away. Hopefully we won't be taking them away, hopefully we'll only be adding them. It's easy to edit a tank mode map, even on the fly while the plant's running. The new mode will only be loaded next time, the new map will only be loaded next time that the thing is running, so you can mess with the whole map system while the actual plant's in operation. You can invent entirely new modes of operation, and the PLC doesn't even have to know about them, as long as the map supports it. And we're using screen widgets, figure programs, and code reuse, meaning that testing is done once, and then obviously we do test it, but we don't expect to find any faults. Questions, comments? Thank you.
So what did you do? This is a plant that's been operating for years.
No, it's under development cycle.
Oh, so you haven't done this transferring before? Or?
By hoses, by bits of pipe, pulling it together. Yeah.
And how often do you change? Like daily, hourly, monthly?
No, it's quite an involved process where over the last few years they just bolted bits and pieces together. You had to go through and actually stop them in stages because they were just putting things together, mixing different liquids, fertilizers together, and blending it to give the customers. And they've developed a market over 4 years from 7,000 to 300,000 tons a year.
7 to 300.
So it's become a large portion of our business, hence what they're trying to do.
One of the things,
I can see there'd be plenty of mistakes.
Yeah!
Right, and is any of the process dangerous? I mean, if you mix, like, I don't know, one thing with another, does it have a tendency to go bang?
Well, danger-wise, not really go bang. It does have incompatibilities where it can turn into a gel and become very difficult to remove from a tank. So,
does it have any environmental impact?
what you do with the stuff afterwards, would have.
So what I'm thinking here is, does 61511 play any part in this? The Australian standards, has this all been seal rated?
As far as the dangers go, no.
No.
You're not dealing with AN or any of the explosive
Not at that
products.
stage.
No, it doesn't have to be. I mean, the three things that obviously need to be mitigated against are physical damage. So would you lose a lot of money if it went wrong? Environmental damage and damage to people. I mean, if any one of those three is in any sort of magnitude, then you've got to start thinking about a fully automated safety instrumented system.
but that's not my call to make.
No, I appreciate it. I just didn't know.
All that has been brought up.
Okay.
It's the other bomb.
Argument.
The other thing we do in that, can you go back to that graphic of the second or third on the MacroView one? One of the... Keep going. That'll do. When it go back to the green one, it might be better to explain. If you're doing a recycle and the if the operator says, I want to recycle tank 10, any valves that are in the wrong position will have a white, a yellow flashing, or red, orange flashing. That's why you can see the little white sort of gaps in the line. Those are the little squares that go around the valves. If you go back to the big one, there isn't anything in there, is there, Brian? Go back to the other
Sorry,
one.
which one? Back?
Just back one.
Another one?
There's no valve with an outline there. Oh, there is.
Yeah.
So the green one in the thing there will, so the operator will know, oh, that's the valve, and it will also display the valve name underneath the tank. So we're trying to make it that the operator can, if he's trying to do a transfer and there's a problem, it'll flash whichever valve, it'll just flash one of them, it can't flash all of them, and it'll tell him this valve is the problem. When he fixes that one, it'll go to the next one on the route and say, this one is the problem. It's going to be really interesting to see when Glenn and the guys use it, because they haven't used this yet in anger, but to see what their feedback is. When we showed them this, the one thing they wanted to do was change the text. There's text in the tanks, depending what's happening, which is not on that, and they want that to be different colours. So when it was in an alarm state, like the product is wrong, they wanted the text to be in red. When it was okay and running, they wanted it to be in green, so they could see easily what the trap was doing. But it's going to be really interesting to see what's going to happen when they actually start using it.
So, Brian, with the tank map file, does the PLC actually, in the file, is there an attribute or an element that tells the PLC what the actual fluid is that's in the tank?
No, only by number. The PLC's got a number associated with a product.
Yeah.
So it says the contents of the tank is 27, and when you're setting up a transfer to another tank, it checks that the destination contents number is 27 before it lets you.
So what is it, MacroView or the PLC that votes to say which different tank element can mix with another tank element?
You can't.
There's no mixing of any products.
Can't mix. Only transfer.
So a transfer assumes that you're starting with either an empty tank or a part full tank of the same product. So if you're doing something from scratch and you want to say go from 1 to 5, if 5's empty, when you take it from no product to become the contents that it's going to receive, then you can send same to same. When they're actually manufacturing the products, they're doing it at different locations. So this is storage of all finished products.
Can you change, like if a tank used to contain something, now it's empty, can you put something new in it?
Yes.
That doesn't cause problems? Like, obviously, residue that it doesn't physically...
Yeah, first of all, the tank has to be cleaned out.
Oh, okay, so yeah, they're clean.
See, that's where the access level for actually changing what's in each tank resides with the process owner.
Right.
So the operators can't change.
The operators can't change what's in the tank.
No, okay, right.
Only the process owner can.
So even when they're empty, there's still got something specified as what kind of tank they are. Yeah.
Basically, when they empty the product out, when they change products, they have to go through and clean the tank out. Or in the case of, okay, if you're looking at two of the products, they're really like Flexi and Flexi NS, they would only rinse the tank out and drain it. It's not, there's no real cross-contamination. But they have to go through the process of isolating the tank and rinsing it out. These are big tanks.
They are huge.
Just a comment. When the spreadsheet file came up, I thought that would be really hard to visualize, as in what's the actual flow. So this is just I was talking about MacroView Windows Desktop and .NET being, you can leverage the functionality. There are APIs for reading Excel spreadsheets into .NET. And you know the essential diagram, which is the basis for MacroView Studio?
Yep.
That also has a functionality where you can have nodes and connections. So graph theory, and so you can specify a series of nodes, a connection, a type of connection, and then it will rearrange it so that you can see all the interconnections clearly. That could be something, I don't know if it's worth it in this case.
No, not in this case.
But you get the idea? Is that an example of where you can leverage
It'd be
the
very
functionality and then
system.
see the interconnects in a graphical form? Because as someone said earlier, Chris, we're visual. To be able to interpret that is pretty tough.
It certainly would help, and we talked about if the need arises, we talked about writing a graphical front end more or less to the spreadsheet for a first up type of design approach, going with the spreadsheet, and we'll see how often they want to change it. And if necessary, then certainly a graphical management tool for that would be a good idea.
It's very feasible. I mean, you could have a graphical tool in MacroView that if you click on the thing and say, well, we want this open, closed, or
Yeah, I understand, but with MacroView you'd have to do a lot of
You would.
work yourself.
A lot of work.
Well, if you use a component which already does the graph theory, spreading out the nodes and the connections, a lot of the work's done for you. The point of the comment was not this functionality, it was more the concept of leveraging
Leveraging your site.
It may help you, that type of approach would probably help you to work out efficiency-wise what benefits you could get from adding a certain valve in a certain spot. As a modelling tool prior to changing the physical layout, instead of someone having to realise that putting a new valve there would help, you could model it graphically and experiment on paper.
So your changing of the map would be infrequent, not daily. That's monthly or something like that.
I would say that. Go away, But this way, the products in this tanks haven't changed probably for 3 months, 4 months.
And the valving probably hasn't changed.
Changing of the map file would only...
It's all new valves.
Yeah.
The products, you don't change this for products. You only change this map if a valve changes or is added or something, or you put a limit switch on a manual valve, that's when you'll change it.
How frequently do they do that?
Yeah. Right now,
You don't want
you don't want to know.
Okay.
Which is one of the reasons
Well, we did this.
Yeah.
why we have done this, is because they have found so many different sequences in doing this. They're used to doing this by hose and by portable pump. And by putting all this on, a third of those valves have come because of the chance of cross-contamination.
Yeah.
And they've all come since we started. I can think of 3 of them there that came out as a result of this map.
Yeah, because when we started doing this, we discovered all sorts of interesting things. Great, thanks,
I can
Brian.
see why I did your head in.
Yeah.